Alright, guys. Last time we stopped at byte. Let's keep going. Now, this byte variable. It's used like this. Okay. Teacher, how much value can be assigned to this byte variable? What do you mean? Well, if I think about it logically, let's say you have a container. This container has a certain volume, right? Let's a glass. For example, we have a water glass. Don't forget to drink water. How much water can you put in the glass? As much as its volume. If you put in more, it'll overflow. It can't hold any more. So, do these variables have a capacity? I mean, is there a limit to the size of the number they can hold inside? Good question. There should be, right? When we talk about the number of bytes in integer types, how much data can it hold inside? Let's see. I'll try 100. Can it hold 100? It does. I put 200. It underlined it. What's it saying? Let's check. When I hover over it, it gives an error. What does it say? It says required type. So, the type it requires is byte. But it says the one you provided is integer. There's something here we don't know. Alright, 200 was too much. Let me try 150. That's too much as well. Let me try 130. That's also too much. Let me try 120. Aha, it worked. So, it's something between 120 and 130. 125. It worked. 126. 7, 8, 8. Look. 128. It doesn't accept it. What's the limit? It accepts 127. Yes. I found it. The highest value a byte can take is 127. Now, think about this logically. Imagine a number line, okay? A number line. So, you're at the 0 point on the number line. When I move to this side, it's positive. I'm from 0 to positive side. But the number line also has a negative side. Why only think about positives? Does it also have a negative 127? It does. So, how far does the negative side go? For example, can it take 128? Oh, it did. Can it take 129? It didn't. Negative 128 to positive 127. So then, I can write it like this. This number can take a value between negative 128 and positive 127. Makes sense. But there's something that doesn't make sense. Why is it negative 128 and positive 127? It doesn't make any sense to me. If it was negative 128 to positive 128, I'd get it. I'd think both sides are equal. How would it be if it was like that? It actually could have been. Alright, so then, what's the logic behind this here? I mean, what's going on here? What should I understand from this? Now, friends, to understand the logic of variables, you need to understand how memory works. When I talked about understanding the logic of variables in the first lesson, what I meant by understanding that memory model was actually this. Now, the computer uses RAM to store data. It writes the information it gets from you into RAM using ones and zeros. So then, what is the smallest unit of data you can use to store information? It's either a 1 or a 0. Now, to help you understand this, I'm going to show you something. I'll give you an example. I'll give you two boxes and ask you to represent the number 15 for me. 15 with two boxes. It's not that simple, is it? You'd write one here and 5 here, right? The combination of these two makes 15. So, when you write them side by side, it's 15. Good. So how do you figure it out? I mean, you all learned this in elementary school. How do you check if it's correct? You do it like this. You say, the ones place, 1 times 5, 5. The tens place, 1 times 10, 10, right? You add the two together. You say, this number is 15, so that's how you check it. What's this in the decimal system? For example, can you write 10 inside this box? You can't, right? Why not? Because our digits are based on the decimal system. They can go from 0 to 9. There's no value called 10. I mean, there's no single digit for 10. We have the number 10, though. So, what's different in computers, guys? In the boxes we have in computers, I mean, in our boxes, you can put digits from 0 to 9. So, what can you put inside the boxes that the computer itself uses internally, guys? You can put either a 0 or a 1. So, in the computer's box, there's either a 0 or a 1. How does this work? The logic here is actually this. It checks whether current is passing through this circuit or not. If current is passing, it acts accordingly. If not, it acts differently. So, the data stored on the RAM is related to whether that current is passing or not. Guys, that's how it stores data. For example, when your computer crashes or freezes, you know how people say, just turn it off and on, it'll fix itself. The basic idea there is that what we call RAM is a temporary memory unit. It's called random access memory. It's active as long as electric current passes through it. It can malfunction from time to time. Depending on its durability, the data inside can get corrupted and you might get a blue screen. It causes your computer to slow down. When you turn it off and on, all the data in the RAM is cleared, so when you restart, your computer boots up fixed. That's the logic behind it. That's the reasoning behind turning the computer off and on. So, what does that have to do with our topic, sir? What did I say? The processor stores data in the RAM in order to process it. Like I said at the very beginning, let's say you want to add two values together, right? Add 5 and 10. It's very simple. You add it in your head, but if your brain couldn't remember the number 5 that I mentioned, what would you ask me when I said add 5 and 10? What was the first number? That's what you would ask. It sounds very illogical to you. It seems incomprehensible. All right. Now try adding 9,425,949,145 plus 1,999,226. Do you remember the first number I said? You don't remember. Why not? It was easy when you were adding 10 and 5. How does the brain keep track of this? Try to remember the previous number. You can't, can you? That's how computers work. Actually, our brain also keeps the numbers it can remember right in its mind and processes them. Did I make myself clear? The computer, or rather the processor, stores the data it can hold in the RAM and pulls it from there to process. So, you don't process the data directly on the processor. Now, if we continue with this logic, the data assigned to a variable is then stored in the RAM. So when I enter a value into the computer, it takes that information and puts it into the RAM. How does it put it there? As ones and zeros. Now, the variable we call a byte, friends, is made up of a total of 8 little boxes. Our byte variable. Let me show you like this. 8 of these boxes make up 1 byte. Each of these boxes, friends, is called a bit, which is the smallest building block of a computer. Each of these boxes is 1 bit. So friends, what does the thing I call a byte equal to here? It equals 8 boxes. In other words, it means 8 bits. Those bits, bytes, megabytes, and so on, they all originate from these friends. So, the smallest building block in a computer is this box. We call it a bit. It stores 2 values inside. It stores either a 1 or a 0. So, what does 8 boxes store? Now, if it were in the decimal system, you'd just figure it out instantly, right? How many values can 2 boxes store at most? Friends, 100. Including 0, 99 is the last value, so it can store 100 values, right? So, how many values can you store here? How do you calculate it? For example, how do you know how many values can be stored in a byte? Think of it like this. What is the maximum and minimum I can write in these 2 boxes? What can you write in 2 boxes with decimal numbers? In decimal, you can write up to 99. For the minimum, let me put a comma here. You can write negative 99. Can you write 100? You can't. That's the limit. So, what's the maximum you can write in this one? What's the maximum you can write in this data? Let's take a look at that now. Now, you need to write the values here like this. Look, 2 to the power of 0. Whoa, where did that come from, teacher? 2 to the power of 0? I'll explain this to you in a bit, in a clearer way. 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 4, 5, 6, and 7. So, what are they? 2 to the power of 1, 2 to the power of 2, 2 to the power of 3. Now, teacher, where did you get this from? Look, let me show you where I got it from. Now, what do you call this place here? You call it the ones place. What do you call this one? The tens. 10 to the power of 0, 1. 10 to the power of 1, 10. If there was one more box, it would be the hundreds place. What is that? 10 to the power of 2, 100. 10 to the power of 3, 1,000. Aha! With 2, there are 2 boxes here, right? In this one, it takes 2 values, right? This one takes 10 values, including 0. It takes 10 values. Decimal system, 10 to the power of 1, 2, 3. Here, it takes 2 values. 2 to the power of 0, 1, 2, 3. That's the logic. So, where were you just now? Here, for example, let's say we're going to write the value 5. Alright, we'll write the value 5 in these boxes. Normally, if here, you just write 5, right? In the decimal system. How will it be in the binary system? Let me show you. So, I come here, for example. I say 1, 2. 2 to the power of 0, 1. 1 times 1, 1. What's left? 4 is left. Now, what's here? There's 2. Right. Now, can I write 2 in here? I can't. I can either write 0 or 1. Now, if I write 1 here, 2 to the power of 2, 2. 1 here makes 3. 5 needs 2. Come here, how much is this? 2 to the power of 2, 4. So if I write 1 here, it won't work. I'll write 0 here. There, I wrote it. Now, let's come here. How much is this? 2 to the power of 2, 4. What happens if I write 1 here? It becomes 4. So, when I do it like this, since there's a 1 here and a 0 coming from here, this part is 0. Here, since it's 2 times 4 times 1, this part is 4. So, 4 plus 1, I've found 5. Look, then I write 0 in all the other boxes. In other words, I won't let any current pass through these, friends. So, what does this become? What does this part become, since all of these are 0? 0, 0, 0, 0, 0, 1. What does 0, 1 equal? It equals the number 5. So, did we find 5? We did. So, how does the computer store the value 5 inside a byte? Like this. So where is this information stored? Well, your RAM has a bunch of little boxes inside it. When you talk about gigabytes, how many gigabytes is your RAM? 32, 16, something like that. Gigabytes are determined by the number of little boxes inside it, friends. Byte. Look, here I'm saying byte. Those things you call bytes are these. Byte, megabyte, kilobyte, megabyte, gigabyte, right? Then comes terabyte. And these just keep going like that. It's a multiple of 1024, so 1024 bytes make a kilobyte, 1024 kilobytes make a megabyte. 1024 megabytes make a gigabyte. 1024 gigabytes make a terabyte. So, these are just little boxes. Guys, think of it like this. 1,000 boxes, like here there are 8 boxes, right? 8 times 1,000 boxes, 8,000 boxes. 8 million boxes make a byte. 8 billion boxes make a gigabyte. So, when you have 32 of these, if you calculate 8 times 32, you get 256 billion boxes, which corresponds to your 32 gigabytes, for example. So there are that many of these boxes, and ones and zeros are stored inside them. That's how you should think about it. This is the logic of the system. This is how data is stored in a computer. Guys, this is an important point. Now, if that's the logic, let's move on to something else. Let's talk about that negative 128 to positive 120 range. What's the logic there? Guys, the logic there is very simple. Look, now. Let me do it like this. This is the 0 point. Here, we have 127, right? 127. Here, we have negative 128. Now, if you count the values on this side, there are 128 values. If you count from here, including 0, there are also 128 values here. So, how many values are there in total? There are 2 to the power of 56, 256 numbers, boxes, values. So, what does 8 bits correspond to, guys? To 8 boxes. Now, try calculating this and see what you get. Say 2 to the power of and calculate it. With how many boxes do you represent 256? When you calculate it, you'll get the correct answer anyway. So, the basic idea here is that since 0 is included among the positive numbers, there are actually 128 on the positive side and, in total, 128 numbers on the negative side, guys. With these boxes, you can mark and hold this many numbers. So now, there should be something here that makes us wonder. Teacher, when you count the boxes here, when you calculate the boxes like this, okay, you reach 256 numbers, but how will you determine which are positive and which are negative? So, some are positive and some are negative. According to what will this be determined? Look, friends, the capacity of these boxes to store data is 256 numbers. But the range I can reach is between positive and negative. Here's how you calculate it. Look. From here, this side gives you values between 0 and 127. All right. But if you pay attention to this, if you notice, I took one bit out from here. Why? Because that one bit here will decide whether this number, the number on this side, is positive or negative. You got it. The logic is that simple. So this bit, if it has a value of 0, think of it as positive. If it has a value of 1, think of it as negative. Alright, so what happens this way? One bit in this is the sign bit, and the remaining bits are the ones that represent the digits. This way, we can represent negative values as well as positive values here, friends. So, this is how data is stored in computers. Numerical data is stored and processed like this, friends. See you in the next lesson.